So now we're going to look at a question more like a proof. And this question asks us to prove that if a function is differentiable and is increasing, then its derivative is non-negative, which means positive. So to prove this proof can be made easily by some sort of mathematical induction. So first of all, suppose that for all a and b in the domain of f, we have if a is less than or equal to b, then f of a is also less than or equal to b. This is in fact the criteria for an increasing function. This could be made clearer with a graph. So if we are to draw the graph of an increasing function, so we have the graph here, and we're going to draw an increasing function. So for example, I draw an increasing function here that looks like this, and we have a point A and a point B on the graph. So the corresponding points on the y-axis for A will be f of A, and for B will be f of B. So now from here we can see that f of A is indeed less than f of B if A is less than B. So this is in fact the criteria for an increasing function. And by definition, we know that for a differentiable function, the derivative can be found with this expression. We have limit h tends to 0, fx plus h minus f of x divided by h. So if you consider h to be positive first, so considering h to be positive or equal to 0, we see that this expression fx plus h minus f of x divided by h is also positive or equal to 0. Why is this? Because we get the numerator to be positive, and since we said that h is also positive, we get the denominator to be positive as well. So something positive divided by another thing that's positive will always give us something that's also positive. So in the case of when h is, however, negative, we see that this expression here divided by h is also positive. Why is that? It's because we get the numerator to be negative in this case, and since we've considered this criteria here, we also get the denominator to be negative. And we also know that anything negative divided by another thing negative will always give us something positive. So we see that for the increasing function, the derivative function is always positive. Also from this, we know that typically the derivative function denotes the gradient of the function. So for an increasing function we see that looks like this, the gradient is always positive. So by induction, we can always say that for an increasing function where a is less than or equal to b, and if a is also less than or equal to fb, the gradient is also positive, which further claims that our statement here is actually in fact true, and this has been proven.